saying earlier, mole ratios and going from moles of one substance to moles of another substance, it kind of opens up stoichiometry for you, which is this converting thing that we've been doing, getting from one substance to another. So anyway, when we go to write mole ratios, when we go to write mole ratios, what we're going to use, this is a really complicated sounding sentence, but it's not that bad. So let me read it to you and then I'll break it down. The stoichiometric coefficients in a balanced chemical equation provide definite whole number ratios between the species involved in the reaction. So that sounds like not English. So the stoichiometric coefficients are just the numbers out front. Like this really has a 1 right here. So basically the numbers out front in a balanced equation, this is a balanced equation, provide definite whole number ratios. That means I can make those fractions that we've been using to convert those unit conversions between the species. So species just means chemicals. It's the reactants and products in a reaction. Yes, sir?
What is stoichiometric?
Stoichiometry is this, it's kind of what we've been doing where we're starting to convert from one substance to another. And so this thing where we're going to use our hands to convert, that's called stoichiometry. So, and the ratios, or excuse me, the numbers, the coefficients in a balanced equation are the stoichiometric ratios. Those are ratios that we're going to use in stoichiometry. So, as far as like a better definition, I mean, there isn't a there's not like some unknown like hidden special thing. It's just like this math stuff. So anyway, so I'm gonna keep doing that. I'm gonna write a mole ratio for this, and then I'm gonna get you to write one. So basically, I could write, I guess, I don't know, maybe like 24 mole ratios. Is that right? So 3 times. Well, maybe it's 12. But anyway, if, for example, I have 1 mole of CH4. I could write, that's going to be for every, 2 moles of H2O produced. That's a mole ratio. And I just, where did I get, I got to fix that M. I'm not going to be able to sleep tonight. There we go. Where did I get those numbers? Well, I just got them from the balanced equation. That's a mole ratio. So on your paper, write a different mole ratio. Talk to your neighbors if you need to.
Can you write a ratio if they're on like the same side?
Yes, you can write a ratio if they're on the same side. Yes, absolutely. Good question. Right, so let's talk to somebody, and I wanted you to tell me what mole ratio you've come up with. So, what do you have, Callia?
I did 2 moles of oxygen and 1 mole of hydrogen.
Okay. And then Allie was asking me, can I write a mole ratio for something on the same side of the equation? Absolutely. Yes, ma'am.
And it would be okay if we had that on the
Yeah. And so these they could be flipped upside down, absolutely. And so it's just like all the other conversion factors we've been using where, if it's this way, you can certainly flip it upside down because it still equals 1. You're basically using this as your conversion factor. So, you could write this as 1 mole of CO2 for every 2 moles of O2 because that's still true. According to the balanced equation. Yeah, absolutely, that's fine. Any other questions? Okay, so as long as these numbers out front are the coefficients in your balanced equation, then you're good. All right, so let's go ahead and kind of look at this a little bit more in a problem. So what's going to start happening with these questions? Today's kind of the most simple kind. And they're going to start building on each other. So it's really important that you go back to those basic things that I showed you about circling and underlining and putting squares around things. So I'm gonna model that for you right now. How many moles of ClF3? I already know that's a circle. Like I can already tell that's what they want. It's we're gonna be switching from one hand to the other, right? So I don't need to just circle moles. Like I need to circle moles of ClF3 because I have moles of all of these things in this equation, right? So that's what I'm looking for. Any problems with that? Y'all are pretty good with that kind of thing. Can be produced from 8 moles of Cl2. Does that have a buddy? Is that friends with anything? All right, now all these mole ratios are going to be coming from the Bounce equation. So we're actually going to be drawing our squares around stuff in the Bounce equation. So I know I'm dealing with ClF3, so that's one part of my fraction or my mole ratio. And then I know I'm dealing with chlorine. And when we're dealing with these problems and they say in the presence of excess F2, that just means you have plenty of it. If you were making a cake, you got a big sack of flour, but only a couple eggs, like that's your big sack of flour. It's not going to control anything. You don't have to worry about it. We're going to get into limiting and excess reactants a little bit more later in the week. But that doesn't, this just tells you that, hey, don't worry about fluorine. So really, you don't need to worry about it right now. So now I can go through here and I can do this problem like any other problem that we've done. And so I'm going to start with what I underlined, like always. Now please listen to me. Is it okay? I think it's okay. So it just changed colors, whatever. Go dogs, I don't know. But when we're doing these, look, I've graded so many papers, you guys, look at me in the face. What people end up doing is they don't feel like writing down what they're talking about. They just write down moles, like, oh, 8 moles. Well, guess what? You're going to do all this work, and then you're going to start canceling stuff, and you don't even know if it really cancels. Just trust me, like, that's a second. That is 1 second, honest to God. So don't skip that second. Now, that's not really there, okay? But write down what you're talking about. It will keep you from messing up. The people that are not successful with stoichiometry skip steps. So anyway, now I know, see I have 2 to choose from for my mole ratio for my conversion. And I know that chlorine goes on the bottom because I wrote down chlorine. Can you tell I'm like already, you know, maybe I should pick that coffee back up. 1 mole of chlorine. And then that's for every 2 moles of ClF3 produced. And, you know, if I make sure my units are canceling, and I do have what I wanted in the top right-hand corner. I wanted moles of ClF3. And so, you know, this is pretty simple. It's going to be 16 moles of ClF3. When we're doing these stoichiometry problems, there you go, and you have to be concerned about sig figs, you have to know that when you're converting, these are infinite, right? These are infinite, and so I'm going to be limited by what I started with. And this is 2 sig figs, so this is 2 sig figs. Any questions there? Same stuff, except now, you know, instead of talking about feet, inches, and eggs or whatever, we're talking about chemicals. So this like has a seizure right here. Watch. Like what? I don't think that's helpful to me. Okay, so why don't you, on your paper, circle and underline and square up what you need, and then I'll work it out for you, okay? There's some more calculations to do, and there's something like on the wall. Can you track people if you want to leave? Like, I'll keep this rolling.
I think it's time.
Yeah, it's fine. You can go.
Thank you.
You're welcome. What I'll do the rest of the class is I'll keep teaching, and then I'll put up the answer keys for what we got. So just try to get to we have.
I'll watch it tonight.
You will have homework, but you know, you'll be able to get to where we need.
I don't think tonight will be a late thing, so I think I should be able to watch it tonight.
Okay, well, I'll post it right after school, so you, if you're going on the bus, you can watch it on the bus back. I don't know if you can do that on the phone, but it'll be on YouTube, so
Thank you.
no problem. Have fun. some people already working out the rest of the problem. That's fine. What I'm going to do up here is just quietly kind of circle, underline, and box this stuff up, and just kind of work it out. And then you can look up if you're done or you need help. Okay. Okay, so just to make sure we're all in the same place. Again, it's going to say how many moles of ClF3, so I know that's what I'm looking for, can be produced from 6.79 moles of F2. That doesn't have a friend, it's all by itself. I'm going to underline it. I'm going to box up the two chemical species that we're talking about. And so the problem is referring to fluorine, and it's referring to ClF3. And so that's what I'm going to use in my mole ratio. Start with what I underlined. Make sure that my units cancel. And I'm not kidding about writing the substance. You know, we're not dealing with just one substance anymore, so we can't get away with that. So I got 4.53 is my final answer. Anybody need any help with that? Need another second to look at it? You okay? All right. This is, like I said, it's really laying the groundwork for everything forever. So if I seem like I'm being very slow or cautious, I am. All right, so let's look at the next one. How many moles of F2 are needed to produce 72.4 moles of ClF3 in the presence of excess Cl2? So try to see if you can work this one out in entirety by yourself. I'll put it up here on the board after a minute or two. If you need any help, I'll be walking around. Very good. So take a look at my sig fix. I started with 3. The conversion factor is infinite, so I'm going to end with 3. Again, when you have that excess, that's something that you can just kind of not worry too much about. Everybody get 109 moles of F2. And did you say moles of F2? Did you put a unit on it? Did you put a substance on it? Because if you say 109 moles, again, we're not in that part of chemistry where we're just talking about one substance. And if you put moles, I don't know what you're talking about. So you have to tell me which substance as well. Anybody? Any questions? So for some of you, the part of this that you're actually going to struggle with the most is incorporating writing balanced equations. You guys, for the most part, did really well with that part of the class, but you know, you're still going to have to remember how to name stuff and how to balance the equations. And so before you can do all this, I've been very nice, and this has that for you. You'll have to find that out. So anyway, if we take a look at this next one, I mean, this is getting to be kind of a longer question, and it starts to get intimidating. When you have these longer questions, break them up into pieces. And so copper 1 sulfide, remember what the 1 is, not how many, it's the charge, right? So this is copper 1 plus. Copper 1 sulfide is heated in the presence of oxygen gas, produce copper 1 oxide powder, and sulfur dioxide gas, which that powder just means it's a solid. So we're going to go ahead, read the rest. How many moles of oxygen are needed to produce 5.82 moles of copper 1 oxide? So this part down here is what we've been seeing. But before we can do that part, we have to write the balanced equation. So let's take a second. Go ahead and see if you can write the balanced equation for me, and then we'll address step 2. So write the balanced equation for me for step 1. And if some of this is not ringing a bell for you, if I don't want to name things, that's problematic. So you need to talk to me about it. Take it one substance at a time. Yes, sir. Yeah, I think this is a good. I don't know about the balanced equation, but I think that's right. I'm about to do it. So. You may have trouble writing the balanced equation. Maybe the things, the formulas. I'll give you about 30 more seconds to write the balanced equation, and then we can address the second part if you haven't done so already. Alright, so if you needed some help writing the balanced equation, let's address this, like I said, one chemical or one species at a time. Copper 1 sulfide, copper is 1 plus, sulfur or sulfide, is 2 minus. So I would need 2 coppers and 1 sulfur. And it says it reacts in oxygen gas. Alright, and oxygen is diatomic. If you just write an O, then that's not going to work out for you. So it's a part of our little Brinkelhoff. Is that ringing a bell? I know it's been spring break and everything. So anyway, I'm going to produce copper 1 oxide. So still, I'll need 2 coppers because 1 oxygen is 2 minus. And sulfur dioxide gas. So I'm going to have to balance this like we always have. Copper, sulfur, oxygen, copper, sulfur, oxygen. And I can already tell it's going to be really helpful to me to put oxygen last because it's, you know, it's appearing in 2 different formulas on the right-hand side. Do you make any questions before I start balancing? Yes, sir.
Is sulfur oxide even balanced?
Sulfur dioxide is covalent. So
yeah,
you name it. You name it using, well, it's 2 minus and then, you know, they're both negative. So when you get in there both negative, that should kind of ring a bell to you that, okay, now I'm doing covalent. So anyway, I have 2 of these, 1 of those, 2 of those, 2 of those, 1 of those, and 3 of those. So copper and sulfur are looking good. Need to deal with my oxygens here. And so I need some more oxygen on this side. I'm going to put a 2 here, and that's going to give me 4. So basically, I just need 1 more oxygen. How can I get 1 more oxygen? Do I want to mess with this right now? Probably not the best way to go about it. So I'm going to put a 2 here. That is going to give me that 1 more oxygen that I need, but that is going to give me 4 coppers. So I'm going to have to address that, and I'm going to do that by putting a 2 here. That's going to give me 4 coppers and 2 sulfurs. And so now I need to put a 2 here. We're almost done. Don't be scared. And now that gives me 6 oxygens. And I like when you have that little oxygen gas like that because it's real easy to fix. We'll need 3 of those to get my 6. That's a hard balancing equation to kind of start off with as a warm-up, but you know, you should be able to do that. I'm going to start. I'm not going to lie. You might have to sit there for a minute on that. And that's okay. How you doing? If you just follow my steps of like going back to the top, you know, that really does help. You okay? Good. Okay, so we're solving for moles of O2. So, you know, basically what we've done so far, I like to kind of cross off where I am, and when I have really large problems, it just makes me feel a little bit better. So basically, we've covered, you know, all of that. We don't need to read that, because what you're going to do, if you're not a good problem solver and you need to work on that skill, you're going to keep reading that part you already dealt with. So just mark it out, and you don't have to read it again. So how many moles of O2, that's what I'm looking for, are needed to produce 5.82 moles of copper 1 oxide. So if I look at my balance equation, I know I'm dealing with oxygen, so I need that. And I know I'm dealing with copper 1 oxide, so I need that. So those are the 2 substances I'm going to be using in my mole ratio. From here out, you should be able to solve the rest. And if you haven't already solved the rest, please do that on your own. I'll do it quietly on the board. After your sig figs, make sure you're not only writing moles, you're also writing substance. So what chemical are we doing? Hello. Does anybody need help with this one? You okay? So again, we're just going from this palm to this palm. This one step. Okay. What's going to happen tomorrow is we're going to have to go here and then here, and so that's where we're heading. But this is the middle. This is that step that ties it together. Okay, so let's kind of. Did I go backwards? I think I went backwards. Sorry. There you go. And all right. So, oh, that's it. Okay, cool. What we're going to do now is you're going to take a second and you're going to kind of start looking over the practice problems. And you can do this one of 2 ways. I think most of them require that you write and balance equations. If you're feeling kind of rusty on writing and balancing equations, you might want to go through and write and balance all the equations and kind of get that skill going. If you feel good and you're like, okay, I got all the things, just go ahead and start cranking through. I'm going to give you guys like a 5-minute head start, and then I'll put the answer key up with the steps. I didn't attach it because it has like several pages, because it shows all the steps. So get like a 5-minute head start. Go ahead and get started, and I'll put the key up for you here in a minute. And I'll keep the video rolling for the people that are at home just so they can look at it later if they want to. Actually, I'll hit pause and then I'll start it. That's all. Alright, so if you want to start checking 1 through 3, there it is. Oh yeah, good thanks. Well, that's also things, and then that way responds to the products. So you have this, oh, I said it would mix this and
It's like, it breaks down to
What you got?
Oh, I was wondering, can I see if this is in
Alright, so there's 1 through 3. You need to check.
No, he doesn't. He hates that.
Close.
No, yeah, because he's a shy person.
I really
Trust me. Look, I had to hate to see that. For all that.
because something
Julia just said.
I was there. I was there, so I didn't know, and no one's like, oh, I hate it. No one like says like, no one's like, well,
You don't know basketball. Okay.
yeah, and so.
I know you, Brendan. You wouldn't do that. No, don't do that. That's the worst. That's the worst thing you can do. Look, he's
Yeah.
Yeah. Yes.
We agree. And then when my friends was like, what are you trying
Wow, I'm trying to tell you that.
I said, you're wrong.
Check yourself before you write.
I can't even hear this.
Besides, Brendan's the one that doesn't know.
I don't mind. She was a senior. She was my best friend. That's sweet. I was from the Raleigh seniors. So then they left me. So we just here. It's me this year. Like this.
So this is
Wow. You know, don't get out.
Like it ended up, I don't know if I told you this, but I can't even really go because on the legs. Yeah, it's on Jewish. Oh yeah, well, I mean that's it's on Passover. Yeah. I forgot you're Jewish. You told me before. Are your parents Jewish? My mom is, but yeah, it's my parents are religious. I'm religious, but my parents are. They're pretty different. I mean, like my dad's religious. Yeah, my parents are religious. Yeah. McDonald's.
Alright, if you haven't gotten your answers for 1 through 3, check it out and take a picture.
No,
I'm gonna slow it up. You can take a picture, get 30 seconds to step.
DR2 is because it's dying. The dying's not.
It's just weird. Yeah.
Okay, I don't. And it can't be more than 3. That's
You can come on up. You can actually take a, yeah.
That's like, what?
I was talking to Justin. Anybody else need it?
Dude,
Okay.
I think.
Isn't IC that means it's nitrate, it'll be the same as nitrate.
Yes, that's right. That's right. Did I tell y'all like?
I just processed it in my head.
Did I tell y'all that somebody came up with like my rod has hydraulics, so like the like cyanide is hydrocyanic acid. Like that's so much better than what I made up.
My rod has hydraulics. It's cute. That's
So
really
if
cool.
the anion is high, then it's hydrocyanic. So get better at everything.
I'm gonna write that down.
Because you ate acid with the icky, senioritis, and then my rod has hydraulics. All the things.
Blue and red. Yes. I'm sorry. No, this isn't brown. That's probably wrong. Florida. Oh.
strong acid has a pH of 1, and so it's used right. Because it doesn't such a oh, see, I didn't.
They're not doing they might have been, but I don't.
This is the main. So that right here. Those are like weight, the length and the each of those.
Oh.
Do they have any trouble? Number 5, or excuse me, number 6. Number 6 is balance equation. I think that I want to go over that real quick. So let's make number 6. Let's talk about its balance equation real quick, and let's like get the last thing that we do today. Do you guys remember the trick I showed you for combustion? If you don't remember, I'm going to show you again. So what I'm going to do is I'm going to take my white pen and I'm going to erase the coefficients. Hopefully I can like zoom in a little bit. I don't think I can. So this is a super important trick. Not trick. Well, it's a trick, but when I'm looking at combustion, it's always going to be hydrocarbon plus oxygen gives me carbon dioxide and water. I mean, in this class. Combustion just means rapid oxidation, but whatever. So anyway, I know that the C in CO2 is I have 1 carbon and this has 6, so I'm just going to put the same number of carbons on in front of the CO2. And then that number of hydrogen gets multiplied by 2, so I need half as much because 3 times 2 is 6. So this is going to be 3. Now you have to take care of the oxygens. So my like this and this is all balanced, but my oxygens aren't. So I end up having 12 oxygens plus 3 more is 15. So 15, I need a number times 2, well, it would equal 15. So you can go 7.5 times 2 is 15, or you can say 15 over 2. So 7.5 oxygens, and then that's balanced. If you did these small ratio problems with these numbers, it would come out right. But you don't want to have a half or part number coefficient. So anyway, you could just easily fix this by multiplying all your coefficients by 2. And that would be 15 oxygens. And that would give me 12 carbon dioxides and 6 waters. If you don't learn anything else in here, if you're going on to AP Chem or taking it at Highlands next year, this is such an important skill. There's so many problems that just branch from this concept. And nobody who says it is not in any books anywhere, but it just makes life so much easier. So that is, it's not just a trick, it is just good to know. So y'all are going to be ahead of the game by already knowing that. So anybody got in trouble with that? So don't do this for homework. I don't feel like you're ready. And we'll kind of pick it up there, spend a little bit of time on it tomorrow, and you might have some homework tomorrow night. Thanks a lot. Yeah, you can pack up. Thank you.